now we have our next speaker. I would like to introduce Erin Gerber from Lakeshore Environmental. She works with, on wastewater systems, to be sure, and she helped us at Shady Lane. We consulted with her on the system that we put in a few years ago. She was great and passed along some really good practical ideas. And our system, you'll be happy to hear, Erin, is working well and keeping the DEQ happy. So that's our number one goal at the winery, is to keep the DEQ happy, or Eagle, I guess they're called now.
Eagle now. I'm not so sure, but we do our best.
Yeah, so welcome, and I'll just turn it over to you.
Great. All right. I do have some slides, so I will try to share those here. All right. Can people see that?
Yes.
All right. Perfect. So, hi. Hello again. Thank you for the introduction, Andy. Like you said, my name is Erin Gerber. I'm an environmental engineer with Lakeshore Environmental. I specialize in water and wastewater management in private industry, primarily food processing facilities, and then which led me into craft beverage. So today I'm going to be talking about wastewater management considerations and systems for craft beverage facilities in Michigan. Excuse me. This can be quite a big topic, covering kind of a lot of ground. So today I'm going to be primarily talking to craft beverage facilities, like production facilities operating in rural settings. I'll start by offering kind of a brief overview of what is wastewater, who are the responsible parties, a little bit about permitting in Michigan, and then we'll move into some general overviews of typical parameters of concern, design considerations, review some simple systems, and kind of just touch on some options for proper management of this type of process wastewater. So first and foremost, the state of Michigan, Part 22 groundwater discharge rules define wastewater as liquid waste discharged directly or indirectly to waters of the state, result from industrial, commercial, sometimes municipal facilities. And that includes process waste, cooling, condensing, and sanitary sewage. Further, waters of the state includes the obvious lakes, rivers, and streams, but it also includes wetlands and groundwater under Part 22. In practice, this essentially means that anything that washes down the drain in any production area of your facility is considered process wastewater. This includes, your tank washdowns, crush pad activities, rinse activities, daily sanitation practices, anything that is, that's water related, that hits the floor, hits the drains, and has to be disposed of, must be treated as wastewater until proven otherwise. And the responsibility and onus of proper management of the wastewater largely falls to the facilities. A facility is responsible to comply with all rules and applicable rules and regulations, and it's their responsibility to properly manage their process wastewater. In Michigan, this will require a permit from the appropriate agency. And it is the facility's responsibility to apply for the necessary permit. As far as issuing the permits, that responsibility can vary based on the site-specific location or situation. So for rural facilities that are not connected to public waterworks, permits will come from EGLE. That's the Michigan Department of Environment, Great Lakes, and Energy, formerly known as DEQ. They are now known as EGLE. Most commonly, this will be done through a groundwater discharge permit, indicating that effluent or processed wastewater is ultimately discharged to the groundwater through some type of land application system. Discharge directly to a surface water body is available. That would require an NPDES permit. NPDES permits are typically more strict, more stringent, and somewhat complex in both the application process and in the management process of the permit. So we don't see it as often, since it does require quite a bit more upfront treatment. So groundwater is really the most common, but NPDES and surface discharge is available to facilities where that's the best fit. Lastly, facilities that are connected to public works will likely be issued an IPP permit through their local municipality. Those will include limits specific to the local ordinances and the design of that specific public works that you would be discharging to, that design capacity. So today, again, I'm going to focus primarily on those rural facilities and the groundwater discharge permits. This is often the most cost-effective path for Michigan wineries, breweries, cideries, and it's also where I end up getting the most questions. So I'm hopeful that I can touch on those and that we'll also have time for questions at the end. Regardless of jurisdiction, it's important to recognize that the health department is not responsible for permitting processed wastewater. Health departments are responsible for managing sanitary septic only, and very rarely, if ever, cross into processed wastewater. So by default, it is not a health department issue. It'll be either your local wastewater plant or EGLE. Additionally, it should be noted that agricultural operations are managed separate of processing facilities. So there's, the right to farm and all of that, and that is separate. So the permitting discussed here is for facilities receiving raw crops and commodities like grapes, apples, hops, grains, and processing them into craft beverage, generating wastewater through that process. So I wanted to offer a very brief overview of the permitting structure. I do not work for EGLE, so I won't spend a lot of time here. I won't speak for them, and I won't, talk too much about their side of the permitting process. But I did want to offer, it felt pertinent to offer some basics on the permitting program. This is largely, the groundwater permits are issued under Part 22, and there are 3 general tiers that you can see here regarding permitting, ranging in annual fees and also ongoing monitoring requirements for compliance. So Group 3 is kind of the lowest tier. It's the lowest annual fee and typically has the fewest or lowest ongoing monitoring requirements for compliance. And then it works into Group 2, and Group 1 is the highest tier with the highest annual fee and the most quantity of ongoing monitoring requirements, quarterly samplings, weekly samplings, things like that. Those are very site-specific permits for bigger facilities most often. Historically, craft beverage facilities have been permitted under either 2211 or 2210Y permits. No changes to this have been directly announced or communicated from EGLE, but we have seen some changes to permitting from the permitting unit in other areas and in other reissuances separate of craft beverage. So this could change in the future. But I do not have any information or on the direction or any indication of changes from the department today. And like I said, I don't work for EGLE, so I will let them speak to that part, and I'm not going to get into that today. Regardless of the permit type, Part 22 does require facilities to have a certified operator overseeing their wastewater treatment system. So the certification is specific to the type of system that you operate, but that is a requirement of essentially any Part 22 permit that you will receive. And I want people to be aware of that because it is something that gets overlooked occasionally. So getting into some more of the specifics, in a general sense, the typical wastewater parameters of concern are BOD, your nitrogen, and your phosphorus. They're nutrient-related items, with BOD really being the top parameter of concern and consideration. When permitting through EGLE, you will also need to consider your sodium, chloride, your TKN, and your pH. Those are not typically a top concern in the design process, but they will be required for permit wastewater characterization and likely be included in any ongoing monitoring you might have from your permit. From a design perspective, the other parameters to consider are COD and TSS. So that's chemical oxygen demand and total suspended solids. In Michigan, EGLE focuses primarily on BOD for system designs, for on-site treatment systems designs. But outside of discussions with the state of Michigan, a lot of published, or several of the published information that you might find will be provided in COD, which is a similar parameter to BOD, but not exactly the same. A COD value will be higher than a BOD value for the same wastewater stream because it includes basically all chemical oxygen demand instead of just the biological. Also, if you are in a municipality, COD is more often included in a municipality or an IBP permit just due to how ordinances are written. So, but for EGLE's perspective, it's a BOD, not COD. And then for TSS, that TSS is rarely a permitted parameter in groundwater discharge, but it can become a very important parameter when you're designing your system or choosing which system to pursue. This is especially true in breweries due to the nature and the published data of having very high TSS values. But it can be the case in all craft beverage. We've seen it in wineries, occasionally in cideries. Depending on the site operations or standard operating procedures, standing cleaning procedures, those can all kind of contribute to TSS. Again, municipalities will often have a TSS limit for their permits and their systems, but from an EGLE groundwater permits perspective, it's very rarely a permitted parameter, but you're going to want it for design. So when you're looking to characterize your wastewater or you're considering changes or a new wastewater system, you're going to want to, basically analyze your site for all of these parameters, including TSS, to get a well-rounded, full understanding of what you're dealing with in your wastewater stream. Moving into quality and characterization, wastewater from craft beverage facilities are by default considered high strength. That's largely due to their high BOD concentration. Comparatively, typical sanitary septic, sanitary wastewater, BOD concentrations may be 300 to 500 milligrams per liter, while a craft beverage facility BOD concentration could be anywhere from 1,000 to 10,000, occasionally higher depending on the site activities. Contributing factors to this includes everything that's in your process area. That could include spilled fruit, broken fruit, juices, alcohol, sugars, additives, cleaners. All of those contribute to the wastewater strength and the wastewater characterization that you'll need to do for your on-site treatment system. Wastewater quality varies day to day, week to week, site to site, based on what activities are taking place, what the end products at that facility, what's happening today, what happens overall in the year. So it really is site specific. Good cleaning habits and quality source control in the facility will reduce the strength of your wastewater and reduce the treatment requirements on the back end. So I do recommend implementing manageable but high quality housekeeping practices if you want to minimize the investment requirements in your wastewater on the tail end. If you're able to control what goes into your wastewater in the processing area, you'll be able to kind of almost minimize, to whatever extent possible, your wastewater system. It should be noted for wineries specifically, Eagle did prepare a guidance document several years ago reflecting the default design values that are shown here. In my experience, Michigan wineries are often much lower than these data points and these values that you're required to use. So I do believe and recommend that it benefits a facility to collect your own on-site wastewater data for use in the design process, to make sure you're designing exactly for what you are doing and not over designing to, some pretty significant factors of safety from Eagle. So as far as management, a facility largely has two broad options for how to manage it. You either discharge to a municipality in some fashion, or you manage it on site. The municipality is obviously limited in its infrastructure range, so there's a lot of times it's not even physically available, but even so, it does come with specific permitting and ongoing surcharges specific to that local municipality. More often, facilities will need to manage it on site in some manner, and that can range from a simple holding and equalization land application system through a myriad of treatment options up to what we would consider major on-site treatment works, a biological treatment system, an anaerobic digester, things like that, complex on-site treatment systems. Again, today I'm focusing my efforts on the relatively simple on-site management options. Those are typically the most attainable and best suited for, kind of your typical craft beverage facility. So when I'm talking about simple on-site treatment systems, I'm largely referring to equalization with land application. By using land application, the final treatment occurs in the soil column before reaching the groundwater. So wastewater and its nutrients are also used by the crop or the vegetation during the growing season, which is included in the treatment process and the calculations and considerations. But even so, land application does have to be done at a rate that is acceptable to the soils and acceptable to the crop to make sure that that's a successful choice and a successful treatment method. So within this, you've got kind of two stages. First, your first component is going to be your equalization. Typically, that's a series of buried holding tanks, but could also be maybe a lined lagoon system or an above ground tank farm, depending on the site. But anything that's able to, collect your effluent from the facility and mix, day over day for final discharge. Absolute minimum volume, it would be 1 day at peak discharge volumes. Typically, facilities end at about 1 to 3 days of retention time. But in all honesty, in my experience, more holding capacity rarely hurts a facility. The more retention you are able to put in reasonably, the more retention or the increased retention will offer your facility room for growth. You'll have flexibility in your discharge schedule, and you'll be able to better handle slugs or spills that may come from the production area, especially in a seasonal, all hands on deck kind of environment. Things happen, and having a buffer to properly manage and equalize that, I think will go a long way. So it's a good use of your dollar to, put in one more tank if you can fit it and if you can financially do so. Also would recommend making the tank system or your equalization system expandable for, future growth. That equalization stage should also have a settling component. If you have a series of tanks, this can be, one baffled to help knock it out, or one, designed to be still, no aeration, nothing to be added, just to help knock out any settleable solids and clean up that wastewater before the final discharge. And then you'll have your land application area. The size is dependent on your site conditions, available area, wastewater quality, your soils information, which we'll get into a little bit. But it also should be sized and designed to provide a good load rest cycle. You want to be able to either rest the entire system every other day or operate in zones, such that you're not over applying to a single area, even for a short period of time. Land application can be done. It's a very broad term that covers a lot of ground, but kind of some of the common items that I'll hit on are spray irrigation, ridge and furrow, discharge area, drain field, or a drip irrigation system. So first, looking at spray irrigation. This is a common choice for seasonal processors. I see it a lot in food processing. I see it in the craft beverage. It's a very common method. It can be done in a lot of different ways. You can do fixed guns where they're installed permanently and you have dedicated areas. Temporary or seasonal guns is an option. Traveler, or even a truck mounted spray system, all the way through a fixed center pivot. Pivots are usually larger scale, bigger facilities, but they are available for wastewater management and are used frequently for it. Spray irrigation is very good for even distribution. It's a relatively durable system. It's expandable. It provides a very good option for even and quality land application. The system must be pressurized. So in order to maintain pressure on the guns in any of these formats, there has to be some type of pump and pressurized in a pressurized system. And so for that reason, the investment is a moderate on the grand scheme, is a comparatively moderate investment. Maintenance can be minimal to moderate, depending on the type of spray irrigation that you choose. A lot of times investment and maintenance will kind of be inversely related. If you choose a fixed gun system, for example, your upfront investment might be a little bit more, but your ongoing maintenance probably not as much. Whereas you go with temporary or seasonal guns, you're going to have more hands-on requirements and operation maintenance requirements. But maybe a little less upfront, no excavation, things like that. So spray irrigation can be a very good, useful option for craft beverage and gets rid of a lot of water very evenly in a way that Eagle usually likes to see. Next, we have a ridge and furrow system. This is a simple overland flow system in which you create or excavate furrows for direct discharge over the land to a dedicated area. This can be a very cost-effective solution. It's expandable and adjustable to fit your site in your area, your maintenance requirements, things like that. You can kind of play with the ridge and furrow spacing a little bit and some of the angles that you might be dealing with to kind of best fit what you're trying to do and fit it to the area that you're trying to do. And so it can be a very adjustable solution and a very easy for your site. Ridge and furrow can be done on a pressure or gravity system, but you must be mindful of even distribution. If you choose for gravity, that is an acceptable method. but it's important to be mindful and monitor the system to make sure that you are evenly distributing your wastewater throughout the system and not, overloading any one section, either a low spot in the middle or everything's going through at the front. And you can do some things. You can keep it as gravity, but maybe add some pipes or something to promote even distribution. For this one, comparatively, investment is relatively minimal and maintenance is relatively minimal. Subsurface soil absorption, also known as a drain field, is an option. It is a viable and it's successful solution to wastewater. We've seen it done well in many ways. This can be either a passive aeration system, maybe even an active aeration system, or just a buried tile wastewater system. In practice, so while we've seen this done successfully, it is a viable solution. In practice, solids can be an issue. And this is where your TSS analysis in the design process will be important if you're considering a system like this. By burying the system, visual inspections obviously cannot be completed. And so we've seen facilities maybe get a little lax on their best management practices or their standard operating, their cleanup procedures, and accidentally maybe send some solids down the drain that they didn't mean or wasn't designed to do. And that can lead to fouling and failure if it's not corrected and managed properly. So be aware with a buried system of the out of sight, out of mind. Don't forget it's there. Make sure that you're maintaining the level of cleanliness and management that you were planning or doing when you designed it, and make sure that you're not just forgetting about it and taking it for granted because it's buried and you can't visually inspect it. And also make sure you're doing that TSS analysis to have an understanding of what your wastewater is bringing to the system. Filtration is recommended for these systems, but it's not required. A lot of times the tank system is enough to kind of knock it down and offer the pre-treatment. Pressure or gravity is doable. Again, you have to be mindful of even distribution, which is a little bit harder when it's below grade, but it can be done, so be mindful. Investment, minimal to moderate, depending on your site, how deep you have to go to get to good soils. If you decide to do a trench versus a bed, those play into the cost, but overall it's relatively simple and low key. And maintenance is quite minimal, unless in the event that you accidentally send solids to it, that would cause some major costs associated, but provided that you're monitoring it correctly and that it's doing what it was designed to do, the maintenance should be relatively minimal and very manageable. Lastly, I've got drip irrigation. So this can be a subsurface or an overland. It's very good for use in orchards where guns or surface application maybe isn't as manageable. You're not able to, or isn't as reasonable, feasible to put into an orchard. But the drip irrigation has been successful there. It can be highly automated if you want to. So, changing zones and all that can be done in a control panel for a relatively hands-off option. It must be pressurized in order for even distribution throughout the drip lines. So that a pump will be required for this one. If you bury it, the out of sight, out of mind risks, come into play, and TSS analysis is extra important for a drip because the emitters and the design of a drip system is a smaller orifice. You've got to make sure you understand your TSS, and you will require filtration, which because of the filtration primarily, investment for this is moderate to high comparatively. That filter system will usually cost more money. And then you've got all the excavation and the actual drip irrigation infrastructure. Similarly, the maintenance would be largely in that filter system. If you maintain your filter system and it's working appropriately, your drip will work fine and won't require any attention. But if anything happens to that filter system, or you bypass it for some reason, or it goes down, there's pretty major impacts to your drip irrigation system, potentially full replacement if they foul bad enough. So a very viable solution with some mechanical requirements for consideration. If you're not quite able to get to where you need to be with equalization and land application alone, then I kind of move into a simple 2.0 version where you add an element of pre-treatment to the equalization stage. So most commonly, this is a small aeration unit, or maybe even a slight upgrade to a biological retrofit, like the sledgehammer or the nibbler type systems. Those are very good for, your BOD, your pH equalization or adjustment, your nitrogen, depending on the form that you're battling. But for sodium chloride and TSS, you're going to be looking at filtration and source control to monitor or reduce those parameters. That's the best way to address those, is primarily source control, then filtration if needed. Phosphorus is not typically a limiting parameter of concern in a land application system, because most often it's able to be treated and managed either through the soil column or in the crop or vegetation that's growing in the area. So that's not usually required for pretreatment. Your land application systems are largely based on loading. So the preliminary calculations that you'll want to run or have someone run for you are related to loading. You've got your BOD loading and your hydraulic loading. BOD loading is often the limiting factor, and it's a function of flow, concentration, and area. So it's this moving target that you'll need to work out to balance how much pretreatment, how much water reduction, and how much area you'll need for your system. Eagle typically limits at 50 pounds per acre per day. That's usually on a monthly average, but that's the target you're going to want to hit. Hydraulic loading, Eagle typically limits to 7% of the published NRCS data for your site, or 1 inch. They typically don't permit greater than 1 inch to prevent pooling and ponding, but 7% or 1 inch, whichever is lower, is typically going to be your hydraulic loading limit in the permit. Beyond your initial loading calculations, there's several factors to be considered up front. First is going to be your space available too. So because land application systems are largely based on loading, the area required for treatment is inversely related to the amount of pretreatment required for that wastewater. So if you have a really large amount of area available to you, you might not have to be doing as much pretreatment because you can send higher strength effluent to a greater area. But if you're really landlocked or you have a small area to work with, you might be looking at some more pretreatment to help balance out that BOD loading, because it's a factor of all three of those parameters. Soils information, you're going to want to look at your infiltration, the published data for infiltration rates in your area, but you're also going to want to evaluate depth to water. It's not commonly an issue for Michigan, but there are areas with high water table, and that does need to be addressed or considered in your design process. Because you're using the soil as final treatment, you need some distance between where you're applying the water and where you're hitting groundwater. Your site-specific process data, you're going to want to collect your own wastewater samples to make sure you're designing specific to your system. You're going to want to collect samples at various times in the year, different activities, understanding that full year wastewater generation. And then quantifying your wastewater flow volumes. How are you going to quantify this? Are you going to measure it? How are you going to estimate it? evaluating your site for that information. Aesthetics. Do not forget aesthetics. It is very important to be mindful of the experience that you want your staff to have and your customers to have. So even the most perfect, beautiful wastewater treatment system is still a wastewater treatment system, and it still has potential to create nuisance conditions. And so you want to make sure you're mindful of that when you're deciding where to put a land application system or a similar wastewater treatment system. And lastly, be mindful of the maintenance and O&M ongoing costs with your chosen system. So the land application systems I've talked about, at a minimum, they'll require annual harvest of the vegetation or of the crop and routine clean out of the equalization system, the tanks or lagoons. And frequency of clean out will be dependent on your facility, but they will need to be cleaned out on a somewhat regular basis. So when you're looking at how to start managing or upgrade your existing wastewater management system, you want to start with an in-depth review of your facility, understand all of the locations that water is being used, and understand where that water goes. Make sure it's going to a controlled location that you're aware of and that will be covered under this permit. You will only be allowed to discharge wastewater to a permitted area. So you want to make sure you understand where it goes. Ideally, it would all be collected in the same location and treated in a single system. Then you want to quantify your site, collect your samples, determine your flow volumes, and evaluate your soils. Run that through your preliminary calculations, your hydraulic loading, your BOD loading, determine the area you have to work with, and if that's acceptable. And if not, be ready to add a little bit of pre-treatment in your treatment system. It might be an additional cost up front, but it is still likely much lower than a major treatment works, pump and haul, or even direct discharge to a municipality. So if you go step by step, you can make sure that the money that you're spending is necessary for your specific wastewater, and that you're not over designing to meet default values that you might not be hitting for one reason or another. So add pre-treatment if necessary. It's still going to be a low cost, but do it step by step to make sure it's necessary for your site. And lastly, you take all that information and you apply for the necessary permits. Most likely that will be with Eagle's groundwater discharge permit unit. So a couple final considerations to talk through before we get to questions. Remember that craft beverage wastewater is high strength wastewater. It is not inherently toxic or harmful. It's largely a natural material, natural wastewater, but it does need to be properly managed in order to protect the surrounding environment. So while it's not inherently toxic, it does need proper management and attention and treatment. Permitting is required. You will be permitted to discharge to the approved areas. So permits do not mean that you can discharge anything anywhere. You will have a dedicated area that you are permitted to discharge under that permit, and any new areas would be a modification to that permit. A certified operator is required under Part 22 rules, and it is the facility's job to comply with your issued permit. So it's really important that when you get your permit, you are familiar with it and that you know the requirements and are comfortable with the permit that you've been issued, because ultimately it's your job to comply with that. That means, monitoring your flows, your necessary record keeping, your reporting. Anything that's in that permit is going to come up in the permit reissuance cycle, and you're going to have to account for it. So they're not one and done. They're ongoing documents that you need to be mindful of and aware of. And then just the blanket reminder that equalization and land application is a cost-effective option for the vast majority of Michigan craft beverage facilities. The specifics of that are going to be specific to different sites. They're going to be unique for different sites' considerations, their locations, their soils and quality. But it's a flexible system that is available, is approvable, and a very effective option at managing wastewater from these types of facilities. So with that, I tried to leave enough time for questions. I'm happy to answer any. Thank you guys for your time.
Thank you, Erin. Very good info. I was having flashbacks there to the planning stages of all the BOD talk.
Oh yeah.
You'll be happy to hear our system makes regular discharges. Sorry, you get jokes like that all the time about wastewater jokes.
All the time.
Jokes.
It's my life.
So yes, serious questions. We'll get to those. We have a couple here. Hi, Erin. You mentioned that any Eagle permitted facility needs a certified operator on site. What requirements or level of certification and from whom does this operator need to have to properly perform this job for the permit?
Yeah, it's a good question. The certification will be specific to the type of system that a facility has. So the certifications go through Eagle. There's a series of certified operator codes, essentially. Most often, land application has its own. I think it's A1F. It's a relatively simple tier of certification, but I guess that's the answer, is that it goes through Eagle. It's site specific, and it's usually a test and then ongoing submittal for recertifications.
Okay, and regarding the annual clean out of the solids or effluent in the equalization tanks, can you characterize what that might look like, and what is it you do with this biomass or solids that settle out or don't pass through the rest of the system?
Yeah, that's a really good question. Most often those can be land applied, but they have to be land applied under a separate authorization. They shouldn't be land applied to your same system or to the same area that you're applying wastewater. So one, you can choose to just have it pump and hauled, your standard liquid industrial waste hauler can take care of it and manage it. You just pay them to take care of it and it disappears. Alternately, you could go with an AUA permit, which is an agricultural use authorization, which allows you to land apply at an agronomic rate those solids, the sludge.
Right, and what we do is we pre-settle a lot of the gross lees and stuff and don't even allow that to enter the system, and we field apply that in alternate fields, and that has saved us a lot of trouble in that department.
Yeah, absolutely. So if back to the source control item, if you're able to capture it before it hits your wastewater drain, those solids are GAMP and can be land applied without a special permit. That's kind of general accepted practices, your leaves and that kind of stuff that don't enter your wastewater system. But once it hits your wastewater system, it's got to be handled under an AUA or liquid industrial waste hauler. So if you're able to source control it, I think you're going to be better off, like Andy mentioned.
One more here. Do wastewater permits transfer to a new winery owner when the property transfers, or does the new owner need to start from scratch?
No, you should. There's a transfer process, and you should be able to transfer that permit. You'd have to go through Eagle. There's some paperwork to do, but the permit can be transferred to a new entity.
Okay, and that's all that we have in the Q&A. if people want to reach out to you, can you share your email once more in case?
Yeah, absolutely. So you can find me if you look up Lakeshore Environmental. I'm sure you'll get to me. But also the email is first name, last initial. So that's ERING at my-lei.com. So Erin G at mylei.com.
From Lakeshore Environmental.
Lakeshore Environmental.
Okay, and I know they're very busy. You know, I've tried to communicate with Eagle, but they are coming for you. If they haven't come to you yet, they are coming for you.
Yes, you will need a permit. There is no grandfathered facility. It's happening. So I suggest you get your ducks in a row. Don't wait till they knock on your door because it's going to be more difficult than it needs to be.
Yep. Okay, well, thank you very much for joining us today. It's been a pleasure again. And if we get any late questions, I'll send them to your email.
Happy to be here. Thanks for having me. Have a good day.
You too, Erin. Thanks.